Okay, so this video is for your homework tonight, Monday. Some of you may be watching this tomorrow, but for the most part, this is the homework for Monday. To make this foldable, you'll fold both sheets hamburger style. If you have glue at home, go ahead and put glue on the page that says glue, and then attach the two type 2 transition metal binary compounds on top of the glue page, and that will make this foldable here. Okay, so this middle page is on top of the other left-hand side page that said glue. So you've got those two sheets right here in the center that are glued together. All right, in class today we put some compounds into 3 groups. They were all ionic compounds, and the fact that they had a cation and an anion, and that's what was forming the bond, that force of attraction between a cation, which is a positive ion, and an anion, which is a negative ion. So the first type was just a simple one. You had 2 element symbols. One was a metal, one was a non-metal. And the metal was not a transition metal that we shaded in on your periodic table. Alright, the type 2 here in the center are simple compounds also that have a metal and a non-metal, so 2 element symbols, but these will have a transition metal that we have highlighted red on your periodic table, or if you're in my 3rd block class, you highlight it yellow, that require Roman numerals because they can give different numbers of electrons away. Type 3 over here are the ones that have 3 or more element symbols because they contain a polyatomic ion, which could be in the front of the compound like ammonia or mercury 1, or it could end up at the end of the compound with your negative ion. So you have a list of those. Alright, so let's get started on these. Sodium chloride, aluminum oxide, barium sulfide. To write the formulas for these, you have to use your oxidation numbers. So we take sodium chloride, we write the symbol for sodium down, and it has a 1 positive charge because it's in column 1. Chlorine is what that element is. Chloride has the ID ending on that, which means it's chlorine, so we write the chlorine symbol. It is in column 17, so it has a -1 oxidation number. Since the number in front of the positive sign and negative sign are the same number, we don't need to do any crisscrossing that it's asking you to do here. All we need to do is just write the element symbols down. So that formula is NaCl. Aluminum oxide. Aluminum is Al. It has a 3 positive. It's in column 13, so it has a 3 positive oxidation number or ion charge, and the oxygen has a 2 negative charge. It's in column 16, so it gains 2 electrons, so its oxidation number is 2 negative. So on those I have a 3 and I have a 2. So those 2 numbers are not the same. So in order to get the charges to cancel out at the end, I need to do what's called the crisscross. So what we're really doing here is I take the 2 and I'm bringing it down behind aluminum. So Al2. Then I'm going to take this 3 and I'm going to bring it down behind oxygen, so then I have O3, and so that is my compound. Now what you want to watch for is if those 2 numbers have a least common factor that they both can be divided by evenly, then you need to reduce the formula down. Most of these in type 1 you won't need to be to do that. Alright, barium and sulfide. So that's barium. It's in column 2, so it has 2 positive oxidation state. Sulfide is a 2 negative with sulfur. So those two are the same symbol, okay? And so what happens there is if you forget that those units cancel one another out, what you can do on that one is if you forget, it should just be those two numbers cancel each other out because they're both 2s, so it's just BAS for the answer. But if you forget that, and you end up doing this where you crisscross and bring the number down, crisscross, bring the number down, and you end up with BA2, S2, you'll see that those are both 2s, so this formula could be reduced down by dividing both of those by 2. So then BA2 is BA and S2 becomes just S. So it gets you back reduced down. Okay, so we had some examples to do over here on the side. Alright, so it says write the name of the metal. Oh, let me give you an example. Okay, so right here in this blank, you're going to write magnesium. Come on, finger. This is going to be magnesium phosphide, if I can get my finger to write. There we go. Okay, so the first thing you want to do is write the symbol for magnesium down. Your positive ion always goes first, so the cation's always in front, and that's a 2 positive. And then your phosphide is a P with a, and it's in column 15, so it's 3 negative charge for that. Alright, so that number and that number are not equal to one another, so we're going to have to crisscross. So the 3 comes down here, so this is Mg3, and this 2 comes down behind the P. And notice on all these where I've crisscrossed, you do not bring the signs down. Okay, so don't bring the signs down. Alright, so that's magnesium phosphide right there. And for another one, okay, so for another one on this one, let's do lithium, but that doesn't look like it's lithium. Lithium chloride. Okay, so that's CHLORIDE. Doesn't look like it. So lithium has a 1 positive charge because in column 1. Chlorine, 1 negative. So this is LiCl because those two numbers cancel each other out because they're both 1s. Okay, so that's how you write the formulas there.